Now, last thing I want to just look at here is just finishing up the chapter 9 stuff. And there's just one little extra piece that we got to add. And what 9.6 is all about is what's called solving a right triangle, which means filling in the blanks. You're given some information about the right triangle, and you got to fill in all the other pieces. Okay? It doesn't seem like this is enough information, but if we're given either 2 side lengths, that's all we need, or if we're given 1 side length and 1 acute angle, so 1 angle other than the right angle, that's all I need to fill in all the rest of the right triangle. Okay, how is that possible? Well, let's look at 2 examples. This one, we already know how to do. Let's start with that one. How could I fill in all the rest of that triangle? All I'm given is the angle 25, and in this case, the hypotenuse is 13. So I got to fill in all the other stuff. And of course, I know this is a 90-degree angle. That's given to us too, also, I suppose. How can I get the other acute angle? Yes. No. Okay, good. They all have to add to 180, don't they? And if this one's already 90, doesn't that mean the other 2 have to just add to 90 also? So 90 minus 25 would give me my answer, right? These 2 have to add to 90. So what's that going to be? 65. Okay. So we get 65 degrees for that other angle. Good. And now the sides. This is the part that we talked about the other day with our trig ratios, right? If I only know 1 side length, but I know an angle, I can use my SOHCAHTOA relationships to find one of the other sides, right? How can I do that? Let's say we're going to take, let's use this angle. Okay, if that's the angle we're using, and we know this is 13, what if I want to solve for like h, let's say? Okay, what's the SOHCAHTOA relationship that's going to relate that stuff? The side that we know and the side that we're looking for. Which one? S, right? Because for angle 25, isn't this going to be the opposite side, right? And for angle, the 25-degree angle, this down here is going to be the adjacent angle, or side, sorry, gosh. And then this is always, whoops, sorry, never mind. That's not right, is it? Whoops. What is that one always? Sorry. Hypotenuse, how come? Yeah, it's the big one. It's opposite the right angle. So that's H. And then what's this one up here? Yeah, that's the adjacent leg, isn't it? Good. Okay, so then for the 25-degree angle, H and 13 would be the opposite in the hypotenuse. And so that's sine, right? Okay, so let's calculate that. Get rid of all this stuff. Yeah. So then what's that tell us? Sine of 25 degrees, which is just a number, our calculator will tell us, right? Is equal to what ratio? What's the sine ratio going to be in this triangle? Yeah, it's going to be opposite, which is h, over hypotenuse, which is 13, right? Sine equals opposite divided by hypotenuse. Sine 25 is just a calculator number, so what do I do to get the h by itself?
Times sine by 30.
Yeah, good. I'm going to undo dividing the h by 13. I'll divide both sides, or multiply both sides by 13, right? And so h just equals 13 times sine 25 degrees, and that's going to give us some answer that our calculator will tell us. 13 times, well, I've got to check my mode, don't I? Right, if I'm doing a sine, what mode do I need to be in? Degrees. So I hit the mode button, and yeah, degrees is highlighted, so I'm good. Okay, so 13 times sine 25 enter. 5.94. Now they want us to round to the nearest tenth. So we get 5.5? Good. So h over here, we could write that in as 5.5. All right.
Oh, I like it.
Right, getting it? How would I find G then? Could do SOHCAHTOA stuff.
Just
Right.
the vacuum.
Could also use Pythagorean theorem. Take your pick. They're about the same difficulty, I think. If I want to use Pythagorean theorem, though, one thing I want to caution you about, if I'm going to use Pythagorean theorem, wouldn't you agree that in my triangle up here, 13 is the hypotenuse, so G squared plus H squared equals 13 squared, right? If I'm solving for G, I'm going to subtract H squared. And we have a number for H squared now, right? And then square root both sides. Okay, here's my question to you. What, for H, do I want to plug in the number 5.5? I mean, why does that make you a little uncomfortable, plugging in 5.5? It's the decimal that we rounded, isn't it? Right? And so it's not exact. It got changed. It's not really 5.5. It's really that number, which my calculator stores way out there, right? So what do we want to do instead in our calculation, on our calculators?
Plug in the real number.
Plug in that number, exactly. So instead of 5.5, we'll use this one on our calculator. So to find G, we already said that G squared equals 13 squared minus that number squared. So let's calculate that. 13 squared minus that number, I'll just grab it, that number squared gives us that, so that's G squared. Now I just square root that, right?
Yep.
So square root of that guy. And that gives us a very exact answer. 11.78, which rounds to what? To the nearest tenth would be 11.8. But if we had used the 5.5, maybe we would have gotten something like 11.72, which would have rounded to 11.7. Would have been wrong, maybe, right? Might have been right, but it very well might have been wrong. Okay, does that make sense? Okay, we got it. We filled in all the blanks. We solved the triangle. Okay? So that one we already knew how to do. Now there's one additional trick I got to show you. This is the case where we were given one acute angle and one side. What if instead we were just given two sides and no angles? Doesn't seem like enough, but it is. That is enough. Well, but we're not given one of the acute angles, right? So what can we do here? Well, we could write trig ratios for B and C, or B and A, sorry, in terms of those sides, couldn't we? Right? Does that make sense? So for example, if I took, let's take angle A. Here's angle A. Right? If I want to write a trig ratio that involves the two sides I'm given, which trig ratio would that be for angle A? For angle A, this side is going to be, yeah, it's going to be tangent, because this side is opposite. What's this one over here? Adjacent. And then this is clearly the hypotenuse, right? And so the two sides that we know are the opposite and the adjacent. And so if we do our SOHCAHTOA stuff, tangent's the winner this time, right? We would get tangent of A equals 3 over 2, right? Okay, now, how do we get the A that we're trying to find angle A? How do we isolate A when it's stuck inside a tangent? Well, there's a trick. There's a way to do this. Here's how you do it. We're just to undo a tangent, we do what's called an inverse tangent. And that's just a little trick that we just didn't know yet. We know how to undo other things, like, for example, pretty hard things. If you were given this equation, if I was given, like, the square root of x plus 3 equals 19. Well, I'll make that big. Equals 9. How could I solve for x? What would I do to get the x by itself? Subtract 3, and then what? How do I unlock it from the square root? Square it, because squaring undoes square rooting, right? Agreed? Okay, so it's the same kind of concept as that. Only this time, instead of squaring and square rooting, we're going to inverse tangent a tangent. Now, what's that look like? It's weird looking. It looks like this. That's the inverse tangent, right? So if I take the inverse tangent of A, the inverse tangent and the tangent cancel, and I just get an A. I have to do the same thing to both sides, of course, though. So on the other side, I would also get an inverse tangent of, in this case, 3/2. Okay, does that make sense? So that's the trick. Now that's just a button on the calculator. That's all it is. So my final answer then just looks like this. A equals the inverse tangent of 3/2, which is just like a tangent would be for us. If we put a tangent in the calculator, it's just going to give us back a number. Only this number represents angle A. So where is that on the calculator? Well, here it is. Everybody take a look. So if I want to put that in the calculator, notice that behind the sine, cosine, and tangent buttons are inverse sine, inverse cosine, and inverse tangent. Right? Let me make this really big for a second. Let's see if we can see this. You can kind of see that a little bit now. Can you see there behind sine, cosine, and tangent? Can you kind of see that?
Yeah.
Sine to the -1, it looks like. It says inverse sine, inverse cosine, inverse tangent. Oops. Okay, so let's do that then. I'm going to go second tangent is inverse tangent of 3/2 equals 56.3 blah, blah, blah. Rounded to the nearest 10. 56.3, right? So that's the angle, 56.3 degrees. Okay. All right, so that looks like 56.3 degrees. How would I find this one then? Subtract from 90, right? Because these two have to add to 90, right? So I could just say 90 minus that is 33.7, right? Agreed? Okay. Oh, boy, we're out of time. Let's see if we can do one more of those real quick, just the angle part. Oh, and how do we find C? C is easy. Pythagorean theorem. 3 squared plus 2 squared equals C squared, right? That one we've done a ton of times. That's no big deal. The trick, though, is that inverse trig trick. Okay, here's one more. Try one more of these. Here's our triangle. Real quick. See if we can get through this. This time I'm giving you that this side is 10, and this angle is 23. I want you to find that angle up there. Or hold it. No, never mind. That's not what I want to do. Wrong. That side is 10, and go away. And this side over here is 18. Okay? And I want to find, let's find this angle. Call that angle X. Okay, how would I find angle X? Joseph, how would I find angle X? What's the trig ratio there? Yeah, up to 180. True, but I'm trying to find that angle. I don't know any angles except this one. What's the trig ratio? SOHCAHTOA. Which one? You're right. So there's the right angle. So let's go ahead and fill in. Which one's hypotenuse? 18. What's this one going to be? Okay, that's going to be the adjacent one, right? So which one is it? No. Got an A and an H, so what must be this one? Okay, cosine. All right, so cosine of x equals, now we got to get this. Cosine of x equals 10 over 18. So then how would I get x? What's our trick?
Divide by 18.
Well, no. How do I unlock a cosine? Inverse cosine, right? Everybody with me?
Yeah.
So inverse cosine of 10/18, which is calculator work. Gosh, no way. So we do second cosine, 10 divided by 18, and it is 56.25. How about that? That's the size of the angle. Okay? The other one we can find easily then. Make sense?
Yeah.
Good. All right.